Hello and welcome back. In the part 3 of projectile motion video, we will discuss range of a projectile. That is the distance traveled in x direction. For this purpose, we use the expressions derived earlier for velocity at a given instant and displacement of a projectile at a given period of time t. To find time of flight t, we can equate the displacement in y direction to 0 and solve for t. In this equation, v0y is the initial velocity in y direction. Now we discuss about range of ball or displacement in x direction. Since the range is the displacement in x direction, multiplying the scalar component of the initial velocity vector in x direction, which is a constant throughout the flight, with the time of flight t, we get range or distance traveled by the ball in x direction. In this problem, calculate the range of the ball if it is kicked with an initial velocity of 20 meters per second with an inclination of 30 degrees to the x-axis. For the same problem, we calculate the time of flight as 2.04 meter per second in the previous slide. So multiplying this time with the velocity, initial velocity in the x direction, which is 17.3 meters per second, we get the horizontal range as 35.3 meters. Consider another problem where a ball kicked from a building of height 30 meters with an initial velocity of 20 meters per second inclined 30 degree, as we discussed earlier. Find the time of flight and range. In this problem, we find the time of flight to be as 3.7 in the same manner we have discussed previously. And multiplying this time of flight with the initial velocity component x direction, which is 17.3 meters per second, we get the horizontal distance traveled as 64 meters. In summary, the distance traveled by the ball in x direction is given by v0x times time of flight t. v0x is the scalar component of the velocity vector in the x direction, and t is the time of flight of the projectile. Thank you for listening. Keep watching the tied-up video demonstrations of basic physics concepts.